Hello, thanks for listening. I will present this work titled A Network Constraint Hydrothermal Unit Commitment Model in the Day Ahead Electricity Market. In 2015, Mexico joined an electricity market scheme, replacing state control would establish a wholesale electricity market. This market determines the daily scheduling of generators, solving a unit commitment problem. This is a combinatorial problem. This problem determines which generators to operate the next day to meet user demand most economically. The energy produced is transported through an electrical network to meet loads. The objective function to be optimized comprises multiple components, such as offers from thermal generators, hydraulic generators, renewable generators, reserve offers, load purchase offers, and reserve purchase offers. First, nonlinear power flow constraints are incrementally incorporated into the master problem using a cut generators methods. These new added cuts limit the flow on the violet lines within the master problem. Second, we tackle the loss estimation constraints. In this case, we use the method of tangent planes. Third, the main contribution of this work is the handle of the nonlinearity of the hydraulic generators function through the first order Taylor series polynomial. The method proposed in this work incorporates all the mentioned components into an interactive decomposition algorithm between a master problem and a series of sub-problems. These components include the linear approximation of the hydraulic unit generation function, flow calculation in line groups, loss estimation of the system cuts generated by violet line groups. Simulation were conducted using public market data for the winter and summer seasons. The results showed that as more generators were introduced into the system, computational complexity increased. It was also noted that as the number of competing generators increased, economic benefits decreased. The proposed model and method are valuable to determining the production schedule of generators in the day-ahead market. To address the nonlinear features of the problem, several approximation methods were adopted to reduce it to a mixed integer linear model. The most significant contribution of this work is the linearization of the hydropower function using the first order Taylor series polynomial. In conclusion, this model is consistent and applicable to other electricity markets that require hydrothermal coordination. Thank you.